Good morning, students. Today we'll be starting with chapter number 5, Science 1, Heat. In the previous class, we have learnt about what is heat and we have also learnt about different types of heat transfer. Here we will be learning about concepts like latent heat, anomalous expansion or behavior of water, dew point, humidity, etc. Let us begin with latent heat. Before we start with the explanation, there is an experiment that is given to you. Look at the diagram. Take a few pieces of ice in a glass beaker as shown in the diagram. Insert the bulb of a thermometer in the ice and measure the initial temperature. Put the beaker on a stand and heat the ice using a burner. Record the temperature using the thermometer after every minute. As the ice is heated, it starts melting. Stir the mixture of ice and water occasionally. Continue the heating even after the ice starts melting. After some time, draw a graph of temperature with respect to time. Now, you will observe that the temperature of the mixture initially remains 0 degree till the ice melts completely. If we continue heating even after conversion of all the ice into water, the temperature of the water starts rising and reaches 100 degree. At this temperature, again the water starts converting into steam. The temperature of water remains constant at 100 degree till all the water converts into steam. The graph of temperature versus time is shown in the next page. So what do we see? Initially the temperature of ice we know is at 0 degrees Celsius. As you go on heating, you will observe that the temperature does not rise till all the ice cubes or the ice piece gets melted or melts. Then after some time the temperature goes on increasing till it reaches 100 degree. At 100 degree the temperature remains constant till all the water gets converted into steam. The heat energy required to change a substance from one state to another at a constant temperature is called as the latent heat of the substance. We saw the experiment in the previous page. Now look at the graph. This is a graph where the x-axis is showing the time in minutes and the y-axis is showing the temperature. And you can see there are certain lines A, B, C and D. Now let us understand this graph properly. You need to learn this graph and the explanation because you get a lot of interpretation questions based on this graph. Now in this graph, the line AB represents the conversion of ice into water at a constant temperature. When the ice is heated, it melts at 0 degree and converts into water at this constant temperature. So you can see that during the time from 0 minute to 4 minutes approximately, the temperature is remaining constant at 0 degree. The ice absorbs the heat energy during this period and the absorption of the energy continues till all the ice converts into water. The temperature remains constant during this transition. This constant temperature at which ice converts into water is called its melting point of ice, and we know that it is 0 degrees Celsius. Thus, during the transition of solid phase to liquid, that means from ice to water, the object absorbs heat energy but the temperature does not rise. Then where is the heat energy going? This heat energy is used for weakening or breaking the bonds between the atoms or molecules in the solid state and transforming it into liquid state. The heat energy absorbed at a constant temperature during transformation of solid into liquid is called as the latent heat of fusion. So what did we see? That at 0 degree, that is the melting point, ice starts absorbing the heat from outside and it starts getting converting into water. But the temperature does not rise till all the ice gets converted into water. So that means where is the heat being used or the heat that is being absorbed? This heat is being used by the molecules of the solid to break the bonds and get converted into liquid. This kind of heat is called as latent heat of fusion. It is it is defined as the amount of heat energy absorbed at constant temperature by unit mass of a solid to convert into liquid phase is called the specific latent heat of fusion. So this is about the first part of the graph. Now look at the next part. Once all the ice is transformed into water, the temperature of the water starts rising. Look at the graph again. After B, slowly it is becoming, as the time is changing from 6 minutes to 8 minutes to 10 minutes, slowly the temperature is increasing from 10 to 20 to 30 to 40, so on. It goes on increasing up to 100 degree. So the line BC in the graph represents the rise in temperature of water from 0 degree to 100 degree. Now thereafter, even though the heat energy is supplied to water, its temperature does not rise. The heat energy is absorbed by water at this temperature and is used to break the bonds between molecules of the liquid and convert the liquid into gaseous state. This is represented by the line CD. See that line CD at 100 degree. The time is increasing but the temperature is not increasing. Thus, during transformation from liquid to gas, heat energy is absorbed by the liquid but its temperature does not change. The constant temperature at which the liquid transforms into gaseous state is called the boiling point of the liquid. And we know that the boiling point of water is 100 degree. The heat energy absorbed at constant temperature during transformation of liquid into gas is called the latent heat of vaporization. It is defined as the amount of heat energy absorbed at constant temperature by unit mass of a liquid to, to convert into gaseous phase is called as the specific latent heat of vaporization. Regulation. It can be pronounced as regulation also. You may have seen the preparation of an ice ball, what we normally call in Hindi as gola, ice gola. First, an ice slab is shredded and then the shredded ice is pressurized around the tip of a stick to prepare the ice ball or the ice gola. How does the shredded means small pieces of ice, convert into a solid ice ball? If two pieces of ice are taken and pressed against each other for a while, they stick to each other. Why does this happen? You might have observed when a gola wala is making the gola that first they make it into small shred and they press it. And after they press it becomes like a one solid ball of ice. How does this happen? While preparing an ice ball, the shredded ice is pressurized around the tip of the stick. A pressure is applied on it. Applied pressure lowers the melting point of the ice below 0 degree, causing it to melt momentarily. This merges the shredded ice pieces into one. Once the pressure is removed due to the regulation, the freezing point is restored to the original 0 degree and the ice pieces refreezes in the form of a single solid ice ball. There's an activity given to you that suppose you take a slab of ice on a stand as shown on the diagram and hang two equal weights on the two ends of a metal wire and put the wire on the slab as shown in the figure. What do you see? It is seen or observed that the wire slowly penetrates, that passes through the ice slab. After some time, the wire comes out of the ice slab through the lower surface of the slab. However, the slab does not break, means the wire passes from top of the ice layer to the down without breaking the ice. This phenomena in which the ice converts to liquid due to applied pressure and then again reconverts to ice once the pressure is removed is called as regulation or regelation. The melting point of ice becomes lower than 0 degree when pressure is applied. This means that at 0 degree the ice gets converted into water. As soon as the pressure is removed, the melting point is again restored to 0 degree and water gets reconverted into ice again. Now there are certain questions asked over there. Let us see what are the questions over there. In the above experiment, the wire moves through the ice slab. However, the ice slab does not break. Why it does not break? When the wire with the weights attached to its two ends is placed on the ice slab, its weight acts along very small area of contact between the wire and the ice. As a result, pressure gets applied on that part of the ice slab. This lowers the melting point, and due to regulation the wire cuts through the water and shifts downward. As the wire displaces, pressure applied by the wire on the ice slab vanishes and its melting point restores, causing the ice to freeze again. In this manner, the wire moves through the ice slab completely without breaking it. Is there any relationship between latent heat and regulation? The latent heat required to melt layer of ice is provided by the metal wire, and the heat given off on refreezing of the ice is conducted through the wire.